Hey, you. Yeah, you, the one staring at the screen right now. Did you know that at this very moment, you're flying through space at 67,000 miles per hour? No, I'm not joking. It's just that Earth is racing around the sun, and you're tagging along for the ride. And the whole time, you're just sitting there, scrolling your feed, not falling into the void. Magic? Almost. In reality, it's physics. I can see your face. Physics? Seriously? Relax, I'm not here to bore you with equations. I'll explain everything, simply, vividly, and without putting you to sleep. Let's go. You live on a rock. Yep, a giant wet rock covered with people and pizza speeding through nothingness. Around you, absolutely nothing. No air, no sound, no Wi-Fi.
And yet, we don't fall off.
Wait, fall where exactly? There's no down in space. To understand that, you need to meet one brilliant guy, Isaac Newton. If he lived today, he'd have a podcast, a line of Apple merch, and definitely a TikTok channel throwing fruit at people for science.
His biggest hit, the formula F equals ma. In plain English, the harder you kick something, the faster it moves. If you know the object's mass and the force of the kick, you can calculate the path of anything, a football or that slipper you threw at your alarm clock. One day, Newton sat under a tree, got hit by an apple, and thought, why did it fall down and not sideways? That's when he realized that everything in the universe pulls on everything else.
Yes, even you, right now, are pulling on your couch and fridge.
Thus was born the law of universal gravitation. The greater the mass, the stronger the pull. The farther apart, the weaker the pull. In other words, the more burritos you've eaten, the stronger your personal gravitational field. Think about that. Every planet, star, and asteroid is constantly pulling on one another. The sun pulls Earth, yet we don't fall into it because we're moving insanely fast. We're always falling toward the sun, but constantly missing it. That's what an orbit is. Eternal, perfect falling around the target. By the way, don't confuse weight with mass. Mass is how much you there is in you. Weight is just how hard Earth is pulling on you. On the moon, you'd weigh 6 times less, but you'd still be you. Want to feel lighter? Go to the moon. Even gravity takes better selfies there. Now picture this. You drop your phone. Don't actually do that. I once turned my brand new iPhone into modern art that way. So why did it break? Because energy decided to change form. When the phone's in your hand, it has potential energy. It's like it's whispering, let me fall. You open your fingers and that potential energy becomes kinetic, the energy of motion. Then bam! When it hits the floor, that energy turns into sound, heat, and a solid dose of regret. That's the law of conservation of energy. Nothing appears out of nowhere and nothing disappears. It just changes costume. Food becomes energy. Energy becomes motion. Motion becomes heat, and so on. Temperature is just the speed of atoms dancing around. The faster they move, the hotter it gets. Picture a rock concert. When everyone's just nodding to the beat, it's cool. But when the mosh pit starts, it gets hot fast. That's temperature, baby. And when everything turns chaotic, we get entropy, the measure of disorder. The universe loves chaos. Ice melts, order breaks down. Water evaporates, chaos increases. Basically, the universe's golden rule is everything eventually falls apart. Now, a little magic. Flip a switch, the light comes on. That's electrons rushing by. They have charges, positive and negative. The difference creates voltage. And resistance? That's like the security team holding the fans back. Move a magnet near a wire, you get electric current. Run current through a wire, you get a magnetic field. They're like Batman and Robin, inseparable. That's why your phone can charge wirelessly. Magic? Nope, just physics showing off. When you shake an electric charge, it creates a wave, an electromagnetic one. These waves come in many forms: radio waves, microwaves, visible light, ultraviolet, and even deadly gamma rays. Everything you see is just a tiny part of an endless dance of invisible waves. Now, let's talk about what everything's made of. You, me, your desk, all built from atoms. An atom is like a mini solar system, a nucleus in the center, with electrons buzzing around it like hyperactive bees. Look deeper, and you'll find quarks. Up, down, charm, and strange. Scientists clearly had fun naming those. But if an atom has too many neutrons, it becomes unstable and starts to decay, releasing radiation. And that's no joke. Radioactivity isn't a toy or a Fallout side quest. It's the real deal. And now, the king of speed. Light. 186,282 miles per second. Nothing's faster. Light is the Usain Bolt of the universe. It acts both as a wave and as a particle. Yeah, reality's got a split personality. And then Einstein showed up and said, if the speed of light is the same for everyone, time and space must bend. And guess what? He was right. The faster you move, the slower time runs for you. If you flew off into space at near light speed and came back, a year might pass for you, but 10 for Earth. Cool, huh? Just not cheap. He reimagined gravity as the curvature of space-time. Picture the universe as a giant trampoline. The sun is a heavy bowling ball making a dip in the middle. Now roll a small marble. That's Earth, around the dip. It's not pulled by a force. It's just following the curve. That's Einstein's take on gravity. Then came his biggest hit, E equals mc squared. Energy and mass are the same thing. A tiny bit of mass can turn into an enormous amount of energy. That's why an atomic bomb isn't just an explosion, it's that equation in action. And finally, welcome to the quantum world. If you thought things were weird before, buckle up. Here, particles don't exist somewhere, they exist everywhere at once. Seriously, an electron can be here, there, and in the fifth dimension until you look at it. The moment you observe it, it chooses a spot, like a cat pretending it did nothing wrong when you walk into the kitchen. That's called superposition. And there's also the uncertainty principle. You can't know where a particle is and how fast it's moving. You can know one really well, but you'll be clueless about the other. Quantum physics is like an X. You want to know where I am? Then you won't know what I'm doing. So, we've gone from Newton's apple to quantum madness, all just to answer one simple question. Why don't I fall off this rock that's flying through nowhere? If you enjoyed this journey, hit that subscribe button. Next time, I'll tell you why your toast always lands butter side down. And yes, that's pure physics too.